Anybody want to tell me? Well, anybody is just the two of you all. What is this line here? Where does this line go?
That fall directly on the horizontal
Right.
line for the x-axis.
The horizontal. Is this a horizontal line or a vertical line? This is the line x is equal to 0, right? So
Yeah.
is it a horizontal or a vertical?
So,
Vertical, yeah. Because remember, if you have a vertical line, like say this line here, that is x will always be equal to 4 on that line, eh? Yeah.
oh yes, sir.
Yeah, and it's the y values that change in. Yeah. So is a vertical line. So therefore, this is the line x is equal to 0, which is the y-axis. Yeah. Right. And then we want to talk about. Well, now we're talking about x is greater than or equal to 0. Well, you can see greater than or equal to means that I need to draw a solid line. I already did that. Right. And now anything greater than 0 is, we don't need to plot lines and do points and things. It's pretty simple to say that, anywhere in this region, x will be greater than 0, right? So that is the region for that line, yeah? And then we have y is equal to 0, that line, and you could tell that that line will be this axis here, the x-axis is the line y is equal to 0. Because you notice the y values, this is the point 0, 1, 0, 2, 0, 3. No, sorry, 1, 0, 2, 0, 3, 0, 1, 0, 2, 0, 3, 0. So Shizzy, I didn't lose you there, right? You're following?
Yes, sir.
Alright. So obviously now, we don't have to use no points for this because we can see that y being greater than or equal to 0 will obviously be this region on top here, right? And remember, we're only looking for the common region. It'll actually be this whole region over here, the region where y is greater than 0. This whole region here. But you can see where the common region, the two of them intersecting in this little quarter here, is where the two of them is true, right? It's true for that. Yeah. So now we have this line y is equal to negative 4x plus 3. We could tell negative 4x, so it's a line that's going to be sloped this way, right? So let's see the quickest way to plot this line now. When x is 0, right, then this whole thing cancels. So when x is 0, y will end up being 3. Yeah? So that is 1 point. When x is 0, this whole thing gone. So y, it just have the 3 remaining there, right? And let's say when, I want to say when y is 0, but I have to do all kind of subject and formula nonsense. I don't know for that. So let's just say when x is 2, right? 4 2s are 8, so that is negative 8 plus 3, which is negative 5. Correct me if I'm wrong, right? So when x is 2, y is negative 5, right? Caitlin and Shazay, are you okay with all of this so far, right?
Yes, sir.
All right. Yeah. All right, good job. So now I could plot this line 0 on the x and 3 on the y is here, okay? And then 2 on the x and negative 5 on the y is all the way down here. And my line is going to be really crappy because I don't have a ruler here. Right. And now we need to find out, well, okay, that is the actual line. So where is the inequality now? The inequality y is less than or equal to the line, negative 4x plus 3, right? So what I need to do is, well, I don't know if that is this side or if that is this side. I have a hunch that it might be this side though, but it could be this side, who knows, right? So let's see. What I'll do is I'll choose a point on this side. Let's choose 1, 1. That is 1, 1 over there, right? So 1, 1 is on this side. So when x is 1, y will be less than or equal to whatever this turns out to be, right? So negative 4 times 1 is negative 4 plus 3 is negative 1, right? So this works out to be negative 1 at the point 1, 1, yeah? So 1, is 1 less than or equal to negative 1?
Yes, sir.
Alright, so I chose this point here, 1, 1, and I plugged it in the equation, and I saw that that was not true. Right? 1 is not greater than or equal to negative 1. So it has to be this side over here. Let me choose a point on this side over here. Let me choose the origin, 0, 0. Yeah? 0, 0. So I'll come on this side, 0, 0. Right? So when y is 0, 0 is less than or equal to, well, when x is 0, this whole thing gone, so that is 3. 0 is less than or equal to 3. So yes, it is this side over here. So this side over here satisfies the rule. So it's this entire thing here. But if we look at it now, what is the common region that is shaded by all three? Anybody?
Is that little triangle?
Yes.
Between...
So you see that this black line is this side we've shaded. Yeah?
Yeah.
And then the blue line, it's up on top here we shaded. And then the green line, it was this side we shaded. So what you find is that that little triangle there is common to all three. So what does that mean? That means that if you have a point that is inside that little triangle, that point will be true for all of the inequalities here. That's what that means. Yeah? If you have a point that is inside this region, you notice this region is shared by these two. So that point will be true for these two, but it wouldn't be true for this one.
Yeah.
Alright, so the line, well, I guess this is the same line, right? This is the same line as before. So y is less than or equal to 0 is this line here. Greater than or equal to 0, sorry. And it's this region here, because that is where x is greater than or equal to 0. And same thing here, y is greater than or equal to 0. And that's this region here where y is greater than or equal to 0. And we could see that the two of them intersect in this little part here. And now we had to work out this, right? So I like to just choose easy things. Let's just choose x to be 0. Alright, so let's choose x to be 0. When x is 0, now right now I'm actually trying to find points that are on the line, so don't get mixed up. Right now I had to draw this line. I'm going to draw the line y is equal to negative 5x plus 2. I had to draw the line first, right? So I'm going to try to see what happens when x is 0. When x is 0, this whole thing gone, so y will be 2. So my first point is 0, 2. Right? And when x is 1, right, negative 5 times 1 is negative 5 plus 2 is positive 3. So when x is 1, y is 3. So now I could draw the line. 0, 2. When x is 0, y is 2. Right? And when x is 1, y is 3. Wait? No, negative 3, sorry. There. Well, I can see y'all just daydreaming there. Negative 3. Oh no, it was over here. I know that something was wrong there. Right? So so the line will look something like this. And I mean, I'm sure you could tell the same kind of thing, right? So Caitlin, how do we find out which side of the line to shade? You want to try the right side first, right?
Yeah.
So let's choose the point 1, 1. And what we're doing is obviously the point 1, 1 is not on the line. But we're not looking for a point on the line, we're looking for a point in this region. So we have the point x is 1, y is 1. So what that'll give us? That'll give us 1 is greater than or equal to Negative 5 times 1 is negative 5 plus 2 is negative 3. Is 1 less than or equal to negative 3? No. So therefore, we could just pretty much assume, we don't even have to prove it. We can assume that it's this region here. And of course, the common region will be this tiny little triangle here, right? So those two are pretty much the same question. We have here the line y is less than 3. So let's draw the line y is equal to 3 first. Y is equal to 3 is a horizontal line here. So you see the points on the line, all of the x values will change, but the y values will always be 3. Oops. So that's the line y is equal to 3. And so y is less than 3 now will obviously be below the line. Because below the line is where y is less than 3. And so all this region of the graph here. Yeah. So we have this line. We have two different lines here now. That's interesting. So let me draw this one. Let's say when x is 0, y is 4. So 0, 4 is 1 point. And when x is 2, 2 2s are 4. So that's negative 4 plus 4 is 0. So when x is 2, y is 0. Right? So 0 on the x, 4 on the y, and then 0 on the y, 2 on the x and 0 on the y leaves it right there. And we can see that that line definitely looks like a negative gradient. And that line will probably look something like this. Nice. Now let's see what region of the line is true for this line, right? Which region is true? We have, let's choose the origin. Let's choose the origin, 0, 0. So 0, 0 will mean that 0 is greater than or equal to 4. 0 is greater than or equal to 4 is not true. Right? 0 can't be greater than 4 because once x is 0, this whole thing cancels. So you'll only have 4 left over here. Right? So that means that this side of the line is not true. It'll be this side of the line that we will want. Right? And now let's draw this line here. I'll use blue for you. When x is 0, y is negative 2. And when x is 5, y will be 3. Alright, so this is for the line y is equal to x minus 2. When x is 0, y is negative 2. When x is 5, y is 3. So when x is 0, y is negative 2 here. And when x is 5, y is 3. So that goes right here. And so this is the line that we're talking about. Right there. And now I have a feeling it's going to be this little rectangle, triangle thing over here going to be the guy, right? So, so let's see which region is true. Let's try above, since I have a hunch. Let's try testing the point 1, 1. Right? 1, 1 is above the blue line, right? So the point 1, 1, x is 1, y is 1. So that means that y1 is greater than or equal to 1 minus 2 is minus 1. So 1 is greater than or equal to minus 1. Yes, that is true. My hunch was correct. So it will be the above part of this line, and therefore the common region for all three will be this triangle region here. and we do have the points of the vertices of that triangle. Nice. So, Shazay, you got those lines? Yeah, man. This have nothing to do with part A. So we did part A already. I'd like you guys to do part B now. Right? So Inequalities Part B. You'll definitely need graph paper. I will give you 51. I'll give you 9 minutes to complete this. So I have two lines. The line y plus x is equal to 10. So let me draw that line first, and then we have the line y is equal to x, right? So x plus y is equal to 10. So I could see here that when y is 0, x gonna be 10, because 10 plus 0 is 10, right? So I have my first point 10, 0. Yeah. Watch how fast I'm gonna do this, and I don't want to take half hour, right? And then when x is 0, y gonna be 10. So I have the point 0, 10. Makes sense, right? You had to make the work easy for you, yeah? So so now I have the point 0 on the x, 10 on the y, all the way up here. And I have the point 10 on, oh, I don't have 10 on the x. Okay, fine, well, I had to get rid of that point then. So we can see here that if I have 8 on the x, right? All right, let me use 6. I have 6 on the x, right? So if x is 6, obviously y going to be 4, because 6 and 4 is 10. So it's 6, 4. So 6, x is 6, y is 4. So we're talking about that, right? And yeah, it has a negative gradient, and it makes sense that it has a negative gradient. Even though the x isn't negative here, this is not in the form y is equal to mx plus c. We have to put it in the form y is equal to mx plus c. So if we were to take the x and throw it over, indeed we would have y is equal to negative x plus 10. So you can see that it does have a negative gradient, even though it doesn't look like it. You will only see the negative gradient if it is in this form. And that is why it's always important to put a line in this form if you need to, but we don't really need to in this question, right? So I'll try to draw as straight a line as possible here without a ruler. And that is the line x plus y is equal to 10. And then we have the line y is equal to x. And well, this is the line that we kind of started all of this trouble with, the first line that we learned. We know that that is a positive gradient line that goes straight down the middle like this, right? Where all of the points are equal. So if x is 2, then y will be 2. So 2, 2, 5, 5, you know, those are your points there. So 2, 2, and 5, 5. Right? And let me use blue for this line. Now you can see this line passes through the point 0, 0, the origin, right? Because that is y is equal to x. It's not the only line that passes through 0, 0, right? Remember the line y is equal to 2x. Well, you'll also get the origins when x is 0, y is 0 there, right? So that is the two lines that we have to draw there, but then they start to talk about some inequalities now. So we draw the two lines on the grid, all right. So on the grid, shade the region which satisfies the four inequalities. So the first inequality is x is greater than or equal to 0, right? So x is greater than or equal to 0. They have or equal to? Yes, they have or equal to all of them. So this is the line x is equal to 0. The line x is equal to 0 is actually the y-axis. Right? So that's this line here. So that line, all of the points on that line, the x value is going to be 0, right? And x is greater than 0 is going to be this section over here. So we'll try to lightly shade it. This is the section where x is greater than 0. Right? All here, x will be greater. The x value is greater than 0, right? Y is greater than 0. So this is kind of like the questions we were just doing, right? I have y is greater than or equal to 0. So let's draw the line y is equal to 0 first, which is the x-axis. Y is equal to 0. And so greater than 0 will be this region here. Right? And that is where that region will fall if y is greater than 0, right? And now we have less than and greater than. So let me do this one first, because this one seems like less work, right? X is greater than or equal to y. So x is equal to y. Wait, y is equal to what? X is greater than or equal to y. Alright, x is greater than or equal to y, right? So that comes from the line x is equal to y, which is the same as the line y is equal to x, right? So that is this blue line over here. So I'll write it in blue. X is equal to y. It's the same as y is equal to x. So we already drew that line, right? So x is greater than or equal to y, which is that region there. Well, let's choose this point. Let's choose a point over here. And this is the point 1, 3. And in this case, we could see it's not true. If x is 1, y is 3. 1 is not greater than 3. So it's not this region here. It had to be the underneath region. So let me choose the underneath region. Let me choose this point here, 4, 1. Of course, x is greater 4, 1. X is definitely greater than y in this region here. So this whole region will be true. So the underneath region is true here. Okay. And now we have to shade this one. This one is a less than, right? So x plus y is less than or equal to 10. Let's choose, and that is this green line. I'll draw it over in red, just so that we don't get confused. This line here, that's the first line we draw. Right? So let's see if it's on this side of the line or on this side of the line. Let's choose the origin. The origin is 0, 0, right? So I'll plug that in, 0, 0. 0 plus 0 is 0, which is less than or equal to 10. Well, it's less than 10. So yes, this region is true. So is this underneath region here? And which region is true for all of them? Well, we could see the red line underneath the red line here, underneath the blue line here, on this side of the black line here, and but is only this part of the green, is only this part is true for the green. Right? This part here is true for the green, the red, the blue, and the black, and therefore this here is the region, the common region for all of them. So did you all get that, or did you all even reach here? No, I want to apologize again up front, because these questions will bend your mind, but they're not that hard, don't worry. Right? So they are worded the questions. Yes, I'm sorry to say. I'd like everybody to take 2 minutes, read through this entire question, make a little note, something. I'm not asking you to answer the question at all, and no, don't answer the question. Make little notes, something, and then we'll talk about it. So take 2 minutes, read through this question nice and slow and careful, right? This whole thing is understanding that whole concept of less than and all them kind of thing. Yeah. So let me get into it, right? A florist makes bouquets of flowers such that X roses consisting of X number of roses and Y number of orchids. So immediately, I read in the rest of the question, immediately I'm thinking, well, okay, I have some X and Y going on here. If I have X number of roses and Y number of orchids, then adding them together, that'll give me the total number of flowers, right? So I just thinking out loud here, right? For each bouquet, she applies the following constraints. Ooh. Right? The number of orchids. Orchids is which one? Y. All right. Must be at least half the number of roses X. Caitlin, what do you think that means? How could I express this? Right. So the number of orchids is Y, right? Must be at least. So what does at least mean? Forget the half and thing. What does at least mean? At least means greater than, or at least means less than? Right. Think about it, right? Caitlin, I have a gun to your head and I want at least $2. Does that mean I want less than $2 or I want more than $2? Caitlin, the gun to your head, you know. Caitlin, give my answer now. Right, no, I have a gun to your head, Caitlin, and I'm saying, hey, I want at least $2. At least $2 is what you have to give to me. What does that mean? Does that mean I want more than $2 or less than $2?
Why?
Huh?
Why?
So I want less. Nah, you would, I guess, shoot Fred. I want at least $2 means the least amount of money I want from you is $2. You understand? Right? So I want more, greater than, or equal to. Right? So if Y is greater than or equal to 2, that means that I want at least 2. It can't be less than 2. It had to be greater than 2 or equal to 2. Yeah. Well, I'm going to see in the next question if you understand, right? So, the number of orchids, Y, must be at least. So that means at least means it greater than or equal to half the number of roses. Right? So this is the first equation here. There must be at least 2 roses. But you see the point I'm making there, Caitlin? Right? At least, if I want, you know, you're hungry, so I want at least 3 Skittles. That means I want 3 Skittles at least. I don't want less than 3. You understand, Caitlin? So if you want at least 3 Skittles, that means you want 4, you want 5, you want the whole bag, right? You want the whole bag, but you can't get the whole bag because you have to share it with the rest of the class. So what's the least amount that you will accept? Well, give me 3. I can live with 3. I don't want less than 3. I want at least 3. You understand? Right. No, you can't get less than that because 2 is the least, and that is what the word least mean, and
So it's more than or equal to 2?
X will be greater than or equal to 2. So Caitlin, if X is greater than or equal to 2, that means X could be 3. You agree?
Yeah.
It could be 5, and
Yeah.
it could be 10, and
Yeah.
it could be 457,000, and right? So you can have, that means that I can have 457,000 roses, right?
Yeah.
That means I could have 10 roses, I could have 5 roses, I could have 3 roses, I could have 2 roses, but I can't have less than 2 because I want at least 2 roses. I don't want less. You understand?
Yeah.
You feel like if I bully you? Alright, well then I am trying hard enough then. Right? Shazay, give me this next one. There must be no more than 12. Well, this statement is a little clearer, right? So there must be no more than 12 total flowers. What do you think is the equation here?
X plus Y is less than or equal to 12.
Right. So total flowers. The total flowers, I have roses, X here, plus Y, orchids, and that's the total amount of flowers. And there must be no more than 12 flowers. So I can have 12 flowers, but I can't have more. I can't have 13. So I can have less than 12 flowers though, or equal to 12. So I have these three inequalities here now. So you can see paper 2 could definitely come with a question like this. And really and truly the hardest part of this question is making sure that you come up with the correct inequality, right? So I have these three inequalities here now. Y is greater than or equal to a half X. I have X is greater than or equal to 2. And I have X plus Y is less than or equal to 12. So those are the three inequalities that I have. So they say write three inequalities for the constraints. We just wrote 3. So that is our 3 marks there. Boom. We on. Right? On the answer sheet provided, shade the region of the graph which represents the solution for the set of inequalities in this. Well, obviously we don't have an answer sheet, so what you're going to do is you are going to draw these 3 lines and you are going to shade the region which satisfies all of the inequalities. Alright, so do that now, and I'm only giving you 5 minutes, yeah? So you have to draw these 3. And how I'm going to know is if you look at it here, if you look at this part, state the coordinates of the points which represents the vertices of the region shown. Well, the question tells me that maybe all 3 of them, because this here will be the line X is equal to 2 is a vertical line. This line, this thing here, that is X is equal to 2. Half X probably going to look like this, no, like this, and I'm guessing maybe this one might probably plus 12, so it'll be here. It might look like this or something, I don't know. Alright, it might look like that. And obviously you're gonna get some kind of triangle here. So I want you guys to tell me what is the points of the region of the triangle that that you get. Yes. So so I'll give you 5 minutes, right? You have to draw these 3 and shade the region that satisfies the inequalities, and then tell me what are the points, you know, if of the vertices of that region. Alright, so let's draw the line Y is equal to a half X. So obviously if X is 2, Y going to be a half X, which is 1. Right? And if X is 4, Y going to be a half X, which is 2. Right? And if X is 0, Y going to be a half of 0, which is 0, right? So we have 3 points here on the line, so the line looking something like this. Right? Now I'm not going to get the proper vertices, right? Because I'm not drawing it accurately, I'm just drawing it freehand. So I'm going to depend on you guys to give me the correct vertices. So half X should look something like that. And of course, X is equal to 2, as we were saying, is this line here. And then X plus Y is equal to 12. Well, 6, just on X, just I'll use blue. No, I'll use blue already. x plus y is equal to 12. Well, we know 6 and 6 is 12, so the point 6 should work. Right? And 0, 12, 0 on the x, 12 on the y. I don't have that, right? So, wait, am I doing something wrong? Because shouldn't this, did you guys get a negative for this, right? X plus y, just now, x plus y equals 12. That is the line that I draw in there. So, 6 and 6, yes, when x6, y had to be 6, because 6 plus 6 is 12, right? And then when y is 11, x will have to be 1 to give me 12. So when y is 11, x is 1. That looks like a positive. Oh no, it is a negative gradient line. Okay, good. Right? So again, a line that looking so-ish. And you can see that we definitely have a triangle being formed there. So, right? So let's see. I have a feeling the triangle is going to be the thing. So let's try the first one. Y is greater than or equal to a half x. So y is greater than or equal to a half x. That is the blue line here. So let's try the 0.11, right? Because that is above the blue line. I have a feeling that is it, right? So the 0.11, when x is 1, y is 1, so I'll end up getting 1 is greater than or equal to a half, or 1 is a half. Yes, that is true. 1 is greater than a half. So that means that this entire top region of that line here is true for this inequality, right? Let's try, well, x is greater than 2. Well, x is greater than 2 will be this region here. Okay. And then this one, well, I have a feeling I know what this one is going to be. X plus y is less than or equal to 12. Well, I have a hunch. There's a green line here, so let's try below the green line. Let's try the 0.11. Let me try the 0.11. Sure. You know, because that's below the green line. So the 0.11, 1 plus 1. Oops, I'll do it over here. The 0.11, 1 plus 1 is 2, and 2 is definitely less than or equal to 12, so that is true. So it's this here. And therefore, the shaded region that is common to all of them is this portion over here that is common to all three. And you can see that we have a triangle there. And anybody want to tell me, let me see if I really draw this thing now, right? What is the coordinates for this vertex here?
Which one, sir?
This one here.
That is 210.
And remember, I'm not accurate there, so I hope that you have it accurate. What is the coordinates for this one?
That one should be 84.
84. And what is the coordinates for this one?
21.
2. Nice. So good job, guys. And the florists sell the bouquet of flowers to make, oh my goodness, to make a profit of $3 on each rose and $4 on each orchid. Determine the maximum possible profit on the sale of a bouquet. Interesting question.
X plus y is less than or equal to 12?
Well, let me just see. I mean, the florist sells a bouquet of flowers. So we know that the bouquet of flowers, this has to do with the number of flowers in the bouquet, yeah?
Okay, yeah.
That's what this has to do with. Right? The number of flowers in the bouquet, right? To make a profit of $3 on each rose. So when we're talking about a profit now, we're talking about $3 for every rose and $4 for every orchid. Right? And that is the profit that will be made, right? Determine the maximum possible profit on the sale of the bouquet. Right? So the number of roses that you sell. If you sell 2 roses, right, then you make $3 on each rose profit. So 2 trees are 6, right? And let me see, you sell 5 orchids, right? So 5 4s are 20. So your total profit there is $26. Yeah. What does this graph tell us? Remember what we was talking about there, right? What we was talking about there is we have these inequalities here. First of all, the number of orchids must be more than half, the number of roses. Must be more than half the number of roses. So that's where we got this from, right? So if you're selling a bouquet, if you sell 2, right, half of 2 is 1, right? So I must sell more than 1 of the orchids. So I could have 2 orchids, or I could have 3 orchids, or whatever, right? So it must be greater than half of the number of roses that I sell. So that's what that means, right? There must be at least 2 roses. At least 2 roses. So if I sell 2 roses and 2 trees are 6, then I can't sell 1. I could probably sell 2 orchids with it, right? So I'll make $6. I'll make, with the orchids here, I'll make 2 4 2s are $8. So 6, 8, 9, 10. That's $14 profit I will make, right? So this is interesting. And then we have here that the total bouquet must be less than 12 flowers, or we could see this particular bouquet only have 4 flowers in it, and I make a $14 there, right? So that is interesting. How does this translate to the graph though? What does the graph tell us, right? The graph tells us that, well, okay, the number of flowers, the number of orchids, in this first one, the number of orchids must be greater than half the number of roses, right? So we can see here that this blue line is the line, this region here is where it's true, right? So I could choose a point here, the point 1, 2, and that is true, right? Where, or the number of orchids is twice more than half. Basically twice. You get what I say, right? So, sorry, I don't want to use all that, right? So the thing is, the graph have a lot to do with it, right? You can see here that the number of roses has to be more than 2. So that is the red region here, right? And the number of total in a bouquet has to be, less than the green region here, less than 12. Right? And the triangle gives us the number. Remember, X and Y is the number of flowers, eh? That is what the coordinates mean. This is the number of flowers that we sell in. Right? So is in this region here, right, is where I will be making up my bouquets, because in this region here is where it's true for all of them. So that means that if I want to make a bouquet of flowers in order to make a proper profit, then I will have to make my bouquet with numbers of flowers that will fall in this region. So this point, for example, is the point 4 4. So I could make a bouquet with 4 roses and 4 orchids in it. because that satisfies all of these equations. Yeah, I can make a bouquet with 4 roses and 6 orchids in it, 4, 6, yeah, because that satisfies all of these equations. So the thing is that when it comes to making a bouquet of flowers, right, I want to know, well, in order to make a profit, how much roses should I put and how much orchids should I put? And that is what this graph telling me. This graph telling me that anywhere inside this triangular region, you're going to be safe, because you will satisfy all of the equations. The vertices here now give us the extremes of the amount of roses that you could sell. So, and a way to make note of this, the vertices, why are we concerned about the vertices? Because the vertices will give us either the maximum profit or the minimum profit. Right? Because, and we could see, right? We could see which one of these vertices will give us the maximum amount of profit. So let's see if, let's try this one here, right? Let's call this A, B, and C, right? So for A now, we could see that we have 2 trees are 6 plus 10. So that is what? 6 plus 40. This is 46. Okay. So 46 profit I will make if I sell this amount of flowers, if I arrange my bouquet like this. Okay. If I arrange the bouquet like this, how much profit would I make? I would make 2, 3 by 2 is 6 plus 4 times 1. That is 3 2s are 6 plus 4. That's $10 profit I'll make if I sell this amount of flowers. Right? But if I want to sell this amount of flowers, let's see how much profit I'll make. C. Right? So I'll sell 8 roses plus 4 orchids. 8 trees are how much? 24. Am I correct there? And 4 4s are 16. 24 plus 16 is what? 6 and 4 is 10. That's $40. Right? $40 profit. Right? So we could see here that the maximum amount of profit that I will make, right, is $46. Right? So that is this vertex A over here, where if I sell a bouquet that has 2 roses in it and 10 orchids in it, I will make more money. And that is the maximum amount of profit that I could make. And what you'll find here is this point here. When you plug that into the profit equation, you will get more money than any other point inside of the triangle. Okay? And you notice this B point here, this will be a minimum. Right? So this is the least amount of profit. You can see we're only making $10 on that. Right? So that's the least amount of profit that you could make, and that will be, you wouldn't make less profit. Any other point inside of the triangle will make more profit than this vertex here at point B. So we can see here that out of the 3 vertices, point A represents the maximum profit, and point B actually represents the minimum profit that you could possibly make while satisfying all 3 equations. So you can see here, and this question is beautiful because it shows how linear inequalities could be used by you in your own business. You could actually draw a graph and work out how much things that you could sell to make maximum profit, how much things you should be able to sell in order to make a maximum profit. Good. So you can see here the graph had everything to do with it, right? Because this region, the shaded region here, represents what is the points that are true, that will satisfy all of the inequalities here. right? And so the vertices will give me the maximum and minimum for anything that we want to find, right? Whether it's profit or anything else, right? So let's take a look at one other question like this. And we can see we're dealing with fruit this time, right? So yeah, I'll give you all 10 minutes with this one. 10 minutes is okay, or you want 15? 10 or 15? Take 15 minutes with this.
So, because I see now, tell like that kind of that's just.
Because they didn't ask you nothing about maximum or minimum or nothing else like that. So.
Oh, okay.
So you're seeing the question here, right? Shade on the graph region. Okay. So Trish wants to buy X oranges, Y mangoes, and she intends to carry in a bag. He bag, I think this is supposed to be the bag. And yes, even CSEC does have typos. The bag has space for only 6 fruits, right? And the equation, inequality representing it. So in the bag, I could put X plus Y, but it only has space for 6. So I can't put more than 6. I could put less than 6, but I can't put more than 6. So 6 is the greatest amount that I could put. So Caitlin, you got this equation right?
Yeah.
All right. She said, yeah. Okay, good. So I don't have to pull out any weapons and things. To get a good bargain, she must buy at least. Here is Caitlin's kryptonite here. Right? Caitlin's kryptonite. I like that. So she must buy at least 2 mangoes, right? And inequality for that, right? So to get a good bargain, the number of mangoes has to be at least 2. So it can't be less than 2. It have to be at least 2. So it could be 2 or more. Yeah, Caitlin, you get that one?
Yeah.
Wow. So yeah, have you conquered the least beast? All right, nice. Right. More information about the number of oranges and mangoes associated with it, with a good bargain, is here. So they gave us a good, our next one, Y is greater than or equal to 2x. So what does that say? Somebody tell me, what does this mean in English? Y is greater than or equal to 2x. Y is the number of mangoes, X is the number of oranges. So what does this say? So this means that I must have, in order to get a good bargain, the number of mangoes must be less than twice the number of oranges. Eh? Less than or equal to. So the number of mangoes must be, or I could say no more than twice the number of oranges. So the number of mangoes must be no more than twice the number of oranges. So it could be twice the number of oranges, or it could be less than that, but it can't be no more than that. Right? So write the information represented by this equality as a sentence in your own words. Well, that was in my words. It wasn't in yours. So I go get 2 marks, but only I get none. Okay. Draw the lines associated with the 2 inequalities obtained in 1 and 2 above. So I'm guessing they want this inequality and they want this inequality. Right? And then shade on your graph the region which represents the solution set for the 3 inequalities. So you know what? I'm gonna do this inequality too. Right? I'm gonna do this inequality as well. So X plus Y, let me just write down the trade on this side. X plus Y is less than or equal to 6. X is greater than or equal to 2. And then if I remember, Y is less than or equal to 2x, if I remember. Yes, okay. So these are the three inequalities that are going to check the regions for. First, let's do the easy one first. This one here, x is equal to 2 is the line. So that's this line here. Line x is equal to 2, right? And I could shade it one time. Anything that will be greater than 2 is on this side here. Okay. Let's draw this line now. The line y is equal to 2x. I have an idea how this is going to look. 0, 0 is 1 point on the line. All right, let me do this line in red. All right, y is equal to 2x, and then let's choose if x is 4. 4 2s are 8, so 4 8 going to be 4 8. That's about it there. So this should be my line. That was horrible. So that is the line 2x. Y is equal to 2x. Now let's see what satisfies this inequality. Y is less than or equal to 2x. So we can't try 0, 0 because that's on the line. So let's try this point here, 2, 1. Or let's try the point 1, 1. Because the point 1, 1 is underneath the line, right? So 1, 1. Right? So that means that 1 is less than or equal to 2 times 1 is 2. Yes, that is true. 1 is less than 2. So therefore, it's the underneath here is the region that satisfies that. And I think we had to draw this line now. So I'll do that in blue. X plus y equals 6. Well, I know 3 going to be a point on that. So 3 is 1 point there. And then how about, let me try 1 6, right? No, 1 5. 1 plus 5 is 6, right? So 1 on the x, 5 on the y. So that's it over there. So this line looking something. So and let's shade the region now. So let's try the origin 0 0. 0 0 is 0. So 0 is definitely less than 6. So therefore the underneath is where we shade in here. So that will be this underneath of the line. And we can see, right, that the region where all 3 of them are true will be, this green line going all the way down here. So it'll actually be this region here. Let me just draw it fine. This region of the graph here. Inside of here is the region where all of them will be true. Is that the region that you guys got?
No, sir.
Did I do something wrong?
I think, I don't know if I made a mistake, but I had for the second equation, so that x equal to, I could widen my mistake.
Oh, so you had a horizontal line.
Yeah.
Okay, let me see. What about you, Caitlin? Did you get that region?
Yeah, I did.
Alright, so you got this region underneath here, the region that I put in black.
Yeah.
Alright, that region has blue, it has green, and it has red in it. So I'm guessing that this really is the region here. If Caitlin got it, I do not doubt Caitlin. Yeah? And I guess that is why they didn't ask us for any vertices and things. because this region is certainly not a triangle. Right? So that's it for inequalities. You guys got a taste of the paper 1 inequalities, what that looks like, which is basically just drawing them, and the paper 2 inequalities when it comes to actually interpreting them. And I'd like you to take a look at especially this one, because this one is an important lesson of why these inequalities are practically applicable, especially in your own business where you selling different products. You could actually take those products and form them into inequalities here, and then plot those on a graph and use the shaded region to find out what numbers. So any point inside of this triangle, here will be a bouquet that I could make that will be profitable and that will satisfy all of these 3 conditions. Right? So when you set conditions in your own business, you could use linear inequalities for this. And please remember, the vertices of that triangle, is not just happens. The vertices of that triangle actually tell you where your maximum or minimum is. Right? Whether you're asking for profit, or sometimes they might ask you for something else. But once they use the word maximum or they use the word minimum, you want to check out the vertices there. So everybody cool with that? Does anybody have any questions about this?